Hello mates, in the previous video we just introduced our great circles and we had started to apply them to Earth. So now in this video we are going to use those great circles to see how we are going to come up with a coordinate system for Earth. So one thing I didn't stress in the previous video was this axis here that is perpendicular to the plane of the equator is where the Earth rotates about this axis. The Earth rotates about this axis that connects the north geographical pole and the south geographical pole, just like we did for this orange that I had cut. This axis that we had, we said that's where our orange rotates. So it's the same thing for our Earth. It rotates about this axis here, this north geographical pole to south geographical pole axis. So let's continue to deduce our Earth's coordinate system. What is now going to happen is, okay, for any coordinate system, a good coordinate system does not change with time. It does not change with time. That is a good coordinate system, or a coordinate system is fixed. So the geographers or whoever, I think it's the geographers, they figured out that the equator is always there where it is. The equator is always there where it is. So it was a good starting point. It was difficult making a great circle, not like difficult, but they could have made a great circle like this and an axis for that great circle like this. But for them, it was more appropriate to use the equator. When I say use the equator, in our coordinate system, so let me start a topic here, terrestrial coordinate system. So this terrestrial coordinate system is the longitude and latitude. So let's see where those come in. So on our Earth, we use our celestial equator as our x coordinate. That's where or not x coordinate, as our x-axis. That's where we use that's where we get our x-axis from. You know from mathematics that you have your y and you have your x coordinate, and for you to pinpoint for you to state where a point is, you have to state its x and then its y coordinate. Those are two coordinates that you need to state. So for our Earth, for us to state any point that is there on Earth, our equator is going to act as our x coordinate, as our x, not coordinate, I don't know why I'm saying coordinate. It's going to act as our x-axis. It's going to be our x-axis. So now that we have our x-axis, we now need to define the y-axis. The x-axis is easy to define. It's the celestial, it's the terrestrial equator. The terrestrial equator is our x-axis. Now let's define our y-axis. This needs a bit of explanation, so let's redraw our diagram. This is our equator. It goes at the back there, and this is going to be our axis. This is the south geographical pole, the north geographical pole, and that is the center of our Earth. The center, the core, inside, right inside. It's not on the surface, it's right inside. So this is how it looks, isn't it? That's how it looks. So now when you're looking at our y coordinate, this is what happens. Imagine now we can cut our orange, or our Earth. We can cut our Earth like this, isn't it? We can cut our Earth like this, or we can cut it from an angle like this. So imagine I cut the Earth at an angle like this. The knife will go in through there, and it will come out at the back through there. So I've cut the Earth like this. I've cut it at an angle like this. But this plane where I've cut, it passes through the what? Through the center. So this plane makes a great circle. It makes a great circle because it's passing through the center. That's our definition of a what? Of a great circle. So since I've cut it like this, there's a great circle. I've drawn it like that. Let me cut a bit further again at another angle like this. If I hadn't cut it there, imagine I'd cut it here. I was going to draw a great circle like this. that goes at the back and then comes out like that. So I was going to cut it like that. I was going to cut it like that. It's also a great circle because I'm cutting it in such a way that it passes through the center. So I'm cutting it at angles, but making sure it cuts it goes through the center. Or imagine you're holding an orange. Here I'm just drawing the cuts roughly, but imagine you're holding an orange, and then you cut it in pieces. When you cut here, you turn it, you cut it again, you turn it, you cut it again, you turn it, you cut it again, making sure that you pass through the center every time. If you need a demonstration, okay, let me do this. Imagine this is the cut, and the cut will go at the back like this. This is the cut, it will go at the back like this. So if that is our cut, imagine when you turn, and then you cut again. Okay, this is a small basketball, so it will have these curly things. But imagine this was a straight line, cutting again like this. So it will be another circle. It will be another great circle that is going right round like that. And then imagine I turn, and then I cut it again. It's going to be another great circle going right round like that. And then I turn it, I cut it again. It's going to be another great circle. So these are the circles that I'm drawing. This one here going at the back, and this another one going at the back. So now any plane containing the axis, you see this one, they contain the axis because they're passing through the center. So any plane containing the axis is perpendicular to the plane of the equator. As you can see, this plane of this great circle here that I have drawn is obviously perpendicular to the plane of the equator, because the equator is like this and this one is like that. So they're at 90 degrees to each other. They're at 90 degrees to each other. I hope you can see that, because it's difficult drawing a 3D diagram on a 2D. So just picture this circle that I have drawn and the circle here. So they make something like this. They do something like that. This being the equator, this being the other sphere, this being the other circle that I have drawn. So they make this. So the axis will be like this. Their planes make 90 degrees with each other. So any plane containing the axis is perpendicular to the plane of the equator and cuts the sphere in a great circle known as a meridian. So these great circles are going to be meridians. They are called meridians. Let me write that down. So these are called meridians. So those great circles are the ones called what? Called meridians. And they contain the axis. When they contain the axis, they are automatically perpendicular to the plane of the equator. They are automatically perpendicular. So now that we have our meridians, the meridian which passes through the midpoint of the telescope, so through the telescope at Greenwich, is called the Greenwich meridian. So we have a particular meridian, because these meridians are going to be all over our ball, just like all over our Earth, just like these lines here. But there's a particular meridian that passes through a telescope in a town called Green. Some people call it Greenwich. Some people pronounce it Greenwich. But that meridian that passes through that telescope is called what? Is called the Greenwich meridian. It was just given. It was given a special name because it's easy to locate because of that telescope. It's easy to locate, so it was given a special name. So that meridian there will act as our y coordinate. So our Greenwich meridian is our y coordinate. It's going to be our y, not our y coordinate. I don't know why I'm interested in y coordinates today, but it's going to be our y axis. It's going to be our y axis. So that Greenwich meridian is our y-axis. So to recap what I've said here, our celestial equator is our x-axis. This is going to be our x-axis, the celestial equator, right? But if we are to draw great circles that hold this axis, these great circles here, that have the plane including that their planes include the axis, these great circles, this one here that goes all the way to the back, and also this one here that goes all the way to the back. They're going to be great circles everywhere, even on this side, just like we have on our basket, on this ball here. You see, there are meridians everywhere. There are meridians everywhere. So these great circles here are called meridians. So all of them are meridians, but we choose one special meridian and we call it the Greenwich meridian. It's called the Greenwich meridian because it is a meridian that passes through our telescope, through a telescope in a town called Greenwich in Europe. So that meridian that passes through that telescope is going to be called the Greenwich meridian, and it is going to be our y-axis. So now we have something like this. The equator being our x-axis, and then the meridian that passes through Greenwich, this meridian, this special great circle or meridian as the right name, is going to be our x-axis, is going to be our y-axis. So this one is going to be our y-axis, which is our Greenwich meridian, and this one is going to be our x-axis. And just like we do for mathematics, the x-coordinate is measured on the x-axis and the y-coordinate is measured on the y-axis. So if we have a point here, we are going to locate this point using these two, in reference to these two axes. Just like in mathematics, when you have a flat one like this, when you have a flat coordinate system like this, the x and y, when you have a point, you go down to measure the x-coordinate and you go across to measure the y-coordinate. That's exactly what we are going to do in the next video. This will go down on the sphere to measure our x-coordinate, and then we'll go across to measure our y-coordinate. So we are going to nicely see how to measure our y and see how to measure our x, because it's not going to be the same as a flat surface like this. A flat surface, we can use these rectangular coordinates, but on a sphere we cannot use rectangular coordinates because it's a sphere, it's curved. Due to the curvature, we are going to use angles, but we will see that in the next video, so stay tuned for that one.